So you'll be doing linear inequalities also, no?
Yeah, but not right now. In some
Okay,
parallel
sir.
class.
So in the
Okay.
backup class, no?
Yeah, right, right.
Okay, sir.
I have not started sharing screen. I am sharing it. I was just discussing what we are supposed to do right now. Okay, so let's start with the chapter without wasting any time. The name of the chapter is Permutations and Combinations. So the chapter starts. We'll see what it is about, but first the chapter will start with a notation that is called the factorial. We'll start the chapter with this definition. Okay, the factorial. So you can write it with me. Okay, write together. When I'll be explaining something, then at that time you can listen, otherwise you can note it down. All right. So the factorial, it is the continued product of first and natural numbers. The continued product of first and natural numbers is called n factorial, or factorial n, whatever you say. And it is denoted by, I'm writing the symbols, n followed by exclamatory mark, or we use this symbol also. It is read as n factorial or factorial n. Okay, any of the two notations. And what is the definition? The continued product of first and natural numbers. Okay, what is the meaning? Like for example, just remember this, the continued product of first and natural number. Like for example, if you have to find 5 factorial. Okay, so 5 factorial means the continued product of first 5 natural numbers. We write it like this: 5 into 4 into 3 into 2 into 1. This is the meaning of this term, 5 factorial. 5 into 4 into 3 into 1. Okay, you start with the number whose factorial we have to write, and go on writing the smaller natural numbers following it. Why? Because the definition is continued means you should not miss even a single natural number. So 5 factorial is this. 3 factorial means 3 into 2 into 1. Product of natural number. All the natural numbers. Then 4 factorial means 4 into 3 into 2 into 1. 2 factorial means 2 into 1. 1 factorial means 1. Because continued product of first natural number, that means the number itself. So in that way you can calculate their values. Like when you will multiply all these, in the first one you will get 120, in the second one you will get 6, third one you will get 4 into 3 into 2, that is 24. Here you get 2, this you get as 1. Okay, these are the values. So this is the meaning of the notation n factorial or factorial n. Okay. Now we can write it in a more general way. I hope you are noting everything. Okay, then don't complain later on that we don't have anything. I've already told you you are supposed to make the notes, write everything. And the pace is also very normal, so you can copy it along with me. And whenever I'm explaining something, at that time you can stop and listen. So this is your factorial. Okay, very easy to understand. Now based on this there are some results, but first I will write the definition in a more general way. Suppose I have to write n factorial in the expanded form. Expanded form means like 5 into 4 into 3 into 1, like that. Then n factorial can be written as n into n minus 1 into n minus 2 into n minus 3, and this goes on. This will go on decreasing till 1. You might have observed all the examples here. What do you see? Any factorial ends with 1 only, whether it is 5 factorial, 3 factorial, 4 factorial. Last number is always 1, because that is the definition, product of first and natural number. And I am writing the natural numbers in decreasing order. So number starts from the highest number and ends at 1, because 1 is the smallest natural number. So similarly here, n factorial means n, then the next one will be 1 less than it, n minus 1. Then
Sir,
the
can you
next,
please explain again? So n factorial is equal to n into n minus 1, n minus 2. So what is that?
that is what I'm explaining. You listen first. So
Okay.
n factorial is n into n minus 1 into n minus 2 into n minus 3, and this goes on decreasing till 1. This is the general formula, more general form. Here I just told you 5 factorial. Here I told you 3 factorial. These are specific examples. But if someone asks you what is n factorial, then what is written here on the right hand side? It is the product of first n natural numbers. It is the product of first and natural number. So if you consider these, then if I write 5, what is the next term? It is 1 less than it. So if I say that it is 5, what is 4? 4 is 5 minus 1. 3 is 5 minus 2. 2 is 5 minus 3. Like that. Similarly, this is 3. Next one is 3 minus 1. This is 3 minus 2. So similarly, if I have to write n factorial in expanded form, first number is n. Like here it is 5. This is 3. This is 4. And what are the what are the numbers following it? What are the numbers following it? The numbers following them are 1 less than the previous number. So first number is n, then it will be n minus 1, then it will be n minus 2, then it will be n minus 3, and obviously there are so many numbers. Now you can't go on writing it like this, because see, after n minus 3 I have written and so on too. If you want to write, what you will write after n minus 3? N minus 4, then n minus 5. But there will be no end basically. Okay, you cannot go on writing it like this. Somewhere you have to stop. So where you stop? You stop at 1. This is the meaning. Like for example here, let us try to understand it from here. If I want to find 5 factorial, okay, what I will do? I will put 5 here, okay. I will put 5 here. So let us put, this number is 5. What will be the next number? 4. What will be the next number? 3. What will be the next number? 2. And likewise in this unit, likewise in this formula, the series will automatically end with 1. Okay. Putting n equals 5 in this general formula. This is basically the general formula of n factorial. With the help of this formula, you can
Yes.
find factorial of any number. What happened?
The screen is not visible.
Anyone else? Is it the same problem?
No, sir, it's visible.
Visible.
See, please check your side here. Okay, then similarly, if like it is 7 factorial. If it is 7 factorial, okay, what you will do in place of n, you will put 7. So first number will be 7, next will be 6, then it will be 5, then it will be 4, and likewise it will end at 1. Okay. So remember the general formula as well as you remember the basic thing that it is nothing but simply the product of continued product of the natural numbers, and n will give you the value from where you have to start this expanded form. Like in 5 factorial you have to start with 5, go on decreasing till 1. 3 factorial you have to start with 3, go on decreasing till 1. 4 factorial you have to start with 4, go on decreasing till 1. N factorial you start with n, go on decreasing till 1. And what is the decrease? Decrease of 1, because continuous natural numbers or consecutive natural numbers, they differ by 1 only. That is the reason. Okay. So this is the, till now we have nothing. What we have learned, we have just learned the definition of n factorial. Now based on this, I will be writing some results. Let me take example first and then I will generalize it. Okay. Let us come back to 5 factorial. See, 5 factorial is 5 into 4 into 3 into 2 into 1. I can write it in another form. Listen carefully. Leave 5. Leave 5. What about the product of the next 4 terms? The next four terms, their product, you don't tell the value. Okay, you won't say, sir, it is 24. No, we are creating something else, some other formula. This 4 into 3 into 2 into 1 factorial can now be written as 4 factorial. So if we leave the first term, then it will be the factorial of the next term. Let me take more example. Suppose we have 7 factorial, or let's say we have some another number, let's say 8 factorial. So if I write 8 into 7, 6, 5, 4, 3, 2, 1, and if I leave the first number, then what about this? This is the product of first 7 natural numbers, so I can write it 8 into 7 factorial. Then similarly, if we have 6 factorial, it is 6, 5, 4, 3, 2, 1. So this is 6 into, you can write the next product as product of first 5 natural number as 5 factorial. Okay. So can anyone tell me if I have to write this thing n factorial, n into n minus 1 into n minus 2 and so on. So can anyone tell me what I can write it in the same way? How to write this in the same way?
n
Following
into
these examples.
n minus 1 factorial.
Yes, n into n minus 1 factorial. Observe the pattern. 5 factorial is 5 into 4 factorial. 8 factorial is 8 into 7 factorial. 6 factorial is 6 into 5 factorial. N factorial is n into n minus 1 factorial. Because you write the number and it comes in multiplication of the factorial of a number which is smaller by 1. Like 6 factorial was there, I am getting 5 factorial. 8 factorial was there, I am getting 7 factorial. N factorial is there, I will write n minus 1 factorial. Because one number is already multiplied, and that is like 8 in first case, 6 in second case, and n in this case. So this is just a formula. Just like this is the formula, first one, okay, star mark. Similarly, this is also the formula. It will be used to solve the questions, okay. So based on this, I am writing third important result. These star mark things, this you have to remember, okay. 0 factorial. 0 factorial is 1. Now this thing is not coming by the definition. Okay. 0 factorial is not coming by definition, because definition says that it is the product of first n consecutive natural number. So how you will read it for 0 factorial? Product of first 0 natural number. Product of first 0 natural number will not make any sense. Then how we are getting the value of 0 factorial as 1? And please note, two numbers are there, like 1 factorial, this is also 1, 0 factorial, this is also 1, right? So these two. How we are getting these values? 0 factorial is 1 with the help of previous example here. So what is the proof? Proof is simple. Put n equals 0 in this. We put n equal to 0 in this star marked result, that is n factorial is n into n minus 1 factorial. Put n equal to 0. What will happen? What about LHS? 0 factorial. Wait a minute. Not 0, put 1. Please correct it. Put 1, not 0, put 1. Let us put 1 here. So what will happen? In the LHS, you will get 1 factorial. In the RHS, put n equals 1 everywhere, wherever you see n in this formula. That is the proof that 0 factorial is 1. So in the RHS, it will be 1 into. When you will put 1 here, it will read 1 minus 1, that is 0 factorial. And from here, you will get the answer. Why? Because 1 factorial is 1 by the definition. 1 into something is that number only. So what you get? You get 0 factorial is 1. So a very easy proof with the help of previous result. With the help of previous result, that n factorial is n into n minus 1 factorial. We put n equals 1 on both the sides. In the left hand side, it is becoming 1 factorial. The value of 1 factorial is 1. In the right hand side, it is becoming 1 into 0 factorial. 1 into it is of no use. So ultimately 0 factorial will remain on RHS and this value will come out to be 1. So till now, what you have learned so far, one is the definition. Okay. One is the definition. Second one is this result, n factorial means n into n minus 1 into n minus 2, so up to 1. Then n factorial is n into n minus 1 factorial, and another result is 0 factorial equals 1. So till now, based on these examples, sorry, these results, let us take few examples. Okay.
Excuse me, sir.
Yes.
So 0 is equal to 0 factorial.
Who told you?
And I'm asking.
No, 0 factorial is 1. No, why it will be 0?
So no, because there when you put 1 factorial equal to, it will be 1 into n minus 1. And it will be 1 minus 1 is 0. No, so I got 0 factorial.
You got 0 factorial. No, where you got 0?
So 1 minus 1 is 0. No.
But after that, factorial sign is also there. No? It is not simply 0. It is 0 factorial. So
Oh,
where else
okay.
you are getting
Nice.
0?
Yeah.
Here it is 1 factorial. This is 1. This is 0 factorial. Okay.
Yes,
There
I
is no
understood.
0. There is 0 factorial. There is no 0. Okay. Try to understand.
Yes, I understood.
All right.
So on
Yes.
the proof LHS side, the factorial sign, what happened to it?
Factorial sign.
So yeah, on the LHS of the proof.
LHS of the proof. Yeah. N equals 1. We put n equals 1. It became 1 factorial. 1 factorial is 1 only by the definition. We can't get 0 factorial by the definition. We are getting 1 factorial by the definition. What is 1 factorial? What is 2 factorial? 2 into 1. What is 1 factorial? 1. Why? Because 1 factorial will mean product of first one natural number. So product of first one natural number means what? Simply the first natural number. Okay.
Okay, so understood. Thank you.
Yes. So 0 factorial is coming as a result. And 1 factorial, 2 factorial, all of these are coming by the definition. Okay. So there should not be any confusion. Okay, let us solve some questions. Find value of. Answer these, they are simple. Okay. Find the value of 4 factorial minus 3 factorial. First one. Let us take it as first question. Okay, what is the answer of the first part? Be quick. They are easy questions.
So 18.
Yes, 18 will be the answer. See, why? What is 4 factorial? Answer is so simple. 4 factorial means 4 into 3 into 2 into 1. 3 factorial means 3 into 2 into 1. Find their values. First one is 24, next one is 6. Answer is 18. So that's simple. The answer of second question.
So 28.
28 is correct. See, these are very easy questions. How you will get this value? Write the expansion. See, I'm writing here. What will be there in the numerator? 8 into 7 into 6 into 5 into 4 into 3 into 1. Don't try to calculate their values. Why? Because they'll be cancelled by denominator. What is 6 factorial?
Excuse me,
6
sir.
into, yes.
So we can write 8 into 7 into 6 factorial.
Yes, sure. That will cancel. But since it is the starting, I'm not rushing into the
Okay, sir.
things. Okay. So it will be happening in some time. So 2 factorial. So this is your 6 factorial and 2 factorial is 2 into 1. Okay. Now what will happen? See, all these terms here in the numerator will be cancelled by the denominator in a single go. Okay. Because both, all of them are same. So what is left? If you consider the numerator now, 8 into 7 is written in the numerator and the denominator it is 8 into 2 into 1. So what is the answer? 28. 8 will be cancelled by 2 4 times. 4 into 7, 28. These are the answers. Go on solving this question. Next question, third, fourth. Yes, what about the third answer?
30.
30. Okay, wait a minute, let me check. Yes, correct. You put the values of n and r here. So if you put in place of n, you put 6, you will get 6 factorial. In the denominator, it will be n minus r factorial. That means 6 minus 2. They have given the question. Okay. So this will be 4 factorial. Now you need to solve this. So what is 6 factorial? 6 into 5 into 4 into 3 into 2 into 1. Denominator it is 4, 3, 2, 1. It will become 30. Please note down all the questions, everything I'm repeating. Okay. Don't ask me later on where are the notes. All right. Fourth question.
100.
Yes, correct. Good. Solve next one.
So could you please do the fourth one?
Yeah, I'm just doing it. You multiply both sides by 10 factorial. See, if you consider the denominators of all the terms, then the first term has denominator as 8 factorial, next one has 9 factorial, and last one has 10 factorial as the LCM, right? So what we will do, listen carefully, we will multiply both sides by the highest denominator, that is 10 factorial. So multiplying both sides by 10 factorial means that each term of the equation will be multiplied by 10 factorial. So this will be the result, because in the right hand side we had 10 factorial. So that will be cancelled because I am multiplying by 10 factorial both sides. And LHS, it will be 10 factorial upon 8 factorial plus 10 factorial upon 9 factorial. Now if you are developing the idea of factorial now, then you should try to understand that it is a wastage of time writing 10 factorial as 10 into 9 into 8 into 7 into and so on to 1. You know what is the reason? Just try to do some mental calculation. 10 factorial will contain 10 into 9 into 8 and so on to 1. What about denominator? 8 factorial. 8 factorial will contain 8 into 7 into 6 and so on to 1. It is present in denominator. It will cancel. So what is ultimately remaining? Only those terms will remain which are not present in denominator. Because see, why I have written 10 into 9? Because after that, what is there in the numerator? 8 into 7 into so on to 1, and the same is there in the denominator. It will be cancelled. So why waste time writing all that? Which I have done actually, which I have done in the previous 2-3 questions. But now I'm directly writing the result. Similarly, similarly, can you tell me what will be 10 factorial upon 9 factorial? If you have understood this thing. What can be the answer directly? 10 factorial is your
So 10.
10.
10. That's it. Okay, then what is
Third.
the purpose? Yes. Write it in a short way. What is the sense of writing everything? What is the purpose of writing 10 into 9 into so on to 1? Then in the denominator, you will write 9 into 8 into so on to 1. That will be cancelled. So just write the remaining part and that is your answer. 90 plus 10 is 100. You are supposed to find x. This is the answer. Okay. So multiply both sides by the highest factorial. That will give you the answer very easily. Okay, now let me explain the fifth part to you. See, if you have understood 10 factorial upon 8 factorial is 10 into 9, you will definitely understand how to solve the fifth question because it is in terms of n, but that is not an issue. Okay, tell me, listen carefully. If you can understand this thing, then factorial is complete for you, which is like one exercise in a school book. Tell me, if n plus 2 factorial, I want to write it as n plus 2 into multiplication of a factorial. So, whose factorial will come here? Can you tell me? How can I write n plus 2 factorial as n plus 2 into factorial of what?
n+1.
Yes, correct.
Plus
N
one.
plus 1. Because you know what is the concept of factorial? It starts with the number whose factorial is taken. Like if n plus 2 factorial is there, let me write it here. If n plus 2 factorial is there, then it means n plus 2 into n plus 1 into n, and it will go on till 1, right? So if I am leaving n plus 2 and I want to write remaining as a factorial, then whose factorial it will be? It will be n plus 1 factorial. Okay. This I have actually already discussed. And you will come to know why I am doing it. Now I will do the same process one more time. So now I will write n plus 1, and now whose factorial will remain? N factorial will remain equals 2550 into n factorial. I will cancel this from both sides. You might have noticed I have told you so many times never cancel terms present in both sides which are present in product form. But here I am contradicting myself. Actually, it is not a contradiction. It is right to do this here. Why? See, if you might have observed, the lowest value of factorial is 1. Lowest value means like 0 factorial. 0 factorial is 1. 1 factorial is 1. Okay. After that, 2 factorial is 2 into 1. 3 factorial is 3 into 1. So, all of them are positive natural number. So, what I want to say that factorials always have some positive values. That means they are non-zero numbers, and we can only cancel non-zero numbers from both sides. So it is confirmed that it is a factorial. It cannot have a zero value. So both terms are present on the same terms are present on both the sides. So we can cancel them. After this, quadratic equation will be remaining. Okay, you already know how to solve it, but I will give you even a simpler method than this. You just factorize it 2550. Do the prime factorization of 2550. So we divide it by 5 first. Let us say we divide it by 5. So it will be 510. Let us again divide it by 5. It will be 102. Now we cannot divide it by 5. Let us use 2 here. Then it will become 51. Let us take 3. It will be 17, then 17. That is a prime number. Okay. Whatever I am doing, you listen carefully. Otherwise, you have the option of solving it using quadratic equation. Okay. I am telling you a faster method, but obviously you have to give a thought process also. Okay. Nobody can write simply like this. Needs little bit command, but can be written easily. What I saw that on the LHS, I have n plus 2 into n plus 1. Now, since n is a natural number, So n plus 2 into n plus 1 are basically two consecutive natural numbers. So what I will do in the right hand side also, I will write it like this: 17 into 3 is 51, 5 into 5 into 2 is 50. So you know what is the purpose of writing it like this? Now I can directly compare and tell you that n is coming to be 49. I have compared the bigger number with the bigger value here. If you say, sir, I will compare n plus 1 with 50 as well, so no matter, ultimately it will give you 49 only. So why we are able to do it?
Can
How we
you
are
please tell me
comparing it?
what you did?
That is what I am saying, what I did. You first listen to the whole explanation, then you ask questions, okay? Otherwise, it becomes very difficult to continue the class. So
Okay.
what I actually did, I saw that on the LHS we have two brackets in which we have numbers which are basically two consecutive numbers. Why? Because the numbers are n plus 1 and n plus 2, so they are obviously consecutive. Similarly, what I did, I factorized 2550. I did the prime factorization and I combined terms like this so that I can get two consecutive natural numbers. So in the left hand side we have two natural numbers. In the right hand side also we have two natural numbers. So here we can do the comparison. And how to compare? Obviously, the bigger value will be compared with the bigger term and the smaller value will be compared with the smaller term. When you will do this, you will get the same value n from both of these, that is 49, which is the answer. If you will go for any other combination, then you cannot compare. Like for example, 5 into 5 is only 25. And 2 into 3 into 17, if we take the remaining terms, 2 into 3 into 17, that is 102. So if we write like this, and I say that bigger number is 102 and smaller number is 25, then it will be wrong. You know why? Because in the LHS we have consecutive natural number, where in the RHS we do not have the consecutive natural number. So comparing it like this is absolutely wrong. I am telling you this different method because of a reason that you may be able to solve it quickly. If you can't understand these steps, then does not mean that you won't be able to solve the question. Then what you will do from here, what you will do, you will change it in quadratic and find the factors, and from there you can get the answer. It will become n square plus n plus 2 and 3n plus 2, 2550, n square plus 3n. Now I'm not telling you how to solve a quadratic equation, okay? This is the equation, get n from here. You will be getting two values of n. You will be getting two values of n. Out of that, one value will be positive and one value will be negative. We will reject the negative value of n positive, n negative. We will reject the negative value of n. You know why we will reject the negative value of n? Because let's say negative value of n is, let's say, minus 50, suppose. So if n is minus 50, then it cannot be put in the question itself. Why? Because if you put n equals minus 50 here, then minus 50 factorial. This thing does not exist in mathematics. If you have observed, number started with 1 factorial, 2 factorial, 3 factorial, 4 factorial, and I told you one extra term, 0 factorial. But there is nothing like negative factorial or square roots factorial or decimal factorials. What I say, factorial of negative numbers, factorials of negative numbers, irrational numbers, etc. are not defined. Okay. Factorials of negative numbers, fractions, square roots, anything irrational numbers, they are not defined. Or in simple words, we can say that factorials of whole numbers are only defined because you calculated 0 factorial, 1 factorial, 2 factorial, and likewise. Okay. So whatever anything else is present there, its factorial will never be defined. Okay. Factorials of negative number, fraction, irrational numbers does not exist. Or you can say not defined, it is one and the same thing. So this is for those who can do this process quickly. If you have any problem, you can always go back to the quadratic equation and find roots from there and you'll get the answer. Okay. And just do one thing, put the values of n in the question, especially if negative values are coming, they will be rejected in the question. So you may get to answer, you may leave the question there only, but your marks may be cut because you did not do the verification and you did not reject the negative value. Okay, this you have to understand.
So the method that you just taught over here, so it is only true for consecutive numbers.
Definitely, if no, not for consecutive. It is true for integers. It is not true for consecutive. It is true for integers. Like here, the difference is one. So I am saying consecutive. If like the difference is two, like here it is n plus two, and in one it is n or it is n plus four. We'll try to express 2550 as product of two numbers with a gap of two. Okay.
Okay, sir.
Yes. But generally, if like you find it difficult, you can always go for quadratic equation, and from there you can like solve it. So no issues.
So from the method you showed, both are 49 only you're getting, right?
Yes. You can solve this quadratic equation later on. Go for quadratic formula because making factors may be difficult for you. Otherwise, I tell you what will happen. It will be n plus 52 into n minus 49. You will get these. Okay, I made the factors. You can check it later on. So you'll get two values of n minus 52 and 49. This one will be accepted. This one will be rejected. Okay. So from there also we can see that n is equal to 14. But making these factors may be difficult. So that is why I'm saying you can go for quadratic formula. So this was everything about the factorial notation. All right. Go through these questions whenever you revise. You go through these questions. Okay, that is sufficient. Now, why we have uh, learned this, you will come to know maybe today or in the tomorrow's class. But before that, let me introduce you to one theorem. You will come to know what we are exactly going to do in this chapter. We are going to learn counting. Okay. Now it may seem interesting. Counting, we already know 1, 2, 3, 4. Not that type of counting. Some different kind of counting. Just like in sequence and series, you learn to add. Now you may say, sir, I've learned addition in very junior classes. What type of sum? So you learn to add the terms of AP, terms of GP, terms of AGP, that type of sum. Similarly, here you will be learning counting. What type of counting we will see. So I'm
So
writing
6 question you didn't solve.
which one? Okay, any question left? Okay, this one. Oh, sorry. So you can tell me, it is easy. 6 into 7 into 8 into 9 into 10. We have to write this in the form of PYQ and both of
So
them are
10 factorial
factorials.
by 5 factorial.
Yes, very easy. See how to do it. It is 6 into 7 into 8 into 9 into 10. Okay, what you do, you multiply and divide the missing numbers. So whenever you have to write a factorial, it should always end with 1. Okay, here the numbers are written in ascending order. So I will say that factorial should start with 1. So whatever is missing, you multiply them. So what is missing? 1 into 2 into 3 into 4 into 5. These terms are missing. So if they are missing, you will have to multiply. But if you multiply, you will have to divide also. You cannot change the question. Okay. And as a result, question is over. What you have in the numerator? Now you have in the numerator the product of first 10 natural number. 1 into 2 into 3 up to 10. What is the value? 10 factorial. What is written in the denominator? The product of first 5 natural number. 1 into 2 into 3 into 4 into 5. What is the value? 5 factorial. This is the answer. Because we were supposed to write it in numerator upon denominator form, where numerator and denominator both must be factorials of some natural numbers. This was the question. Okay. Anyone having any doubt till now? Okay, then let us move to the next topic, which is fundamental principle of counting.
So,
What happened?
so could you please again explain how you did that factorization of n plus 1 and n plus 2, and why is it not applicable for non-consecutives?
What factorization? No, see, basically, see this part, this concept is based on mastering this thing. Okay, you can't understand it in one single go that you will be able to make the factors like this. I have given you the idea. If, like in the left hand side, we have the factors where there are two consecutive natural number n plus 2 and n plus 1. So I am trying to create two consecutive natural numbers in the right hand side as well. So I made different combinations. Out of that, 3 into 17, that is 51, and 5 into 5 into 2, that is 50. I got these two also as consecutive natural number. In the left hand side also there are consecutive natural number, so I can compare these two, and the bigger number will be compared with the bigger one. If I take some other combination, they will not be consecutive natural number. Like I take 5 into 2 into 3, 5 into 2 into 3 is 30, 5 into 17 is 85. So if I write this same product, I can write it as 30 into 85 also. But then 30 into 85, there is a gap of 55. And on the left hand side, there is difference of 1 only. So you can't compare. That is what I'm saying. Okay.
Understood.
So we make different combinations and we try to create the same type of numbers which are present in the left hand side. But it is little bit tricky. Okay. Though it gives you answer in a quick way, lack of calculation, but then this thing may be little bit difficult. That is why I'm saying it is not the only method. You can opt for quadratic equation and find from there. Okay, so no problem.
Okay, sir.
Can you explain
Understood.
the sixth question?
What happened in sixth question?
Can you explain it again?
I have just multiplied and divided the sequence, the pattern, whatever is missing. They are asking us to express this as a factorial of, as a division of two factorials. So series is starting with 6 and factorials start with 1. So I have multiplied and divided the missing terms. So 1 into 2 into 3 into 5, 4 into 5, I have multiplied and divided. Now in the numerator it will become 10 factorial. Numerator it will be 5 factorial. That is the explanation. What else?
Yes, understand.
Okay, so next is fundamental principle of counting. Let us see what it is about. Basically, you are learning to count. So there are two methods. Most important is multiplication theorem. Okay. You write this statement with me only. Multiplication theorem. If a work can be done in n ways, can be done in m ways, and another work following it, that word is important, following it, and another work, that means this work will be done after the first work is done, and another work following it, that is why I have written this. Okay, I'm highlighting it. Can be done in n ways, n ways, then the number of ways, then the number of ways of doing the works in the order, number of ways of doing the works in the order equals m into n. Write this sentence. Work can be done in m ways and another work following it can be done in m ways. Then the number of ways of doing the works means both the works. Okay. Both the works in the order. In the order means first you are doing the first work, then you are doing the second work. And as a result, the number of ways of doing both the works in the order are m into n. As the name suggests, multiplication theorem. I will take example also. Just write the sentence first. Okay, let me take the example now. What is this work and ways and why multiplication? Okay, how to relate it with questions. So suppose, so I have a question. Suppose a person has three trousers and two shirts. How many different pairs of a pant and a shirt, or you can write trouser there, pairs of a trouser and a shirt can he dress up with? Can and a shirt can he dress up with? Can you give the answer? Because it is very logical question. Person is having three trousers, two shirts.
Six.
Yes, six.
6.
So obvious. See, I
6.
am telling you one thing. I am telling you one thing. This chapter can be completed within one day only. You know why? Least number of formulae. Just like in trigonometry, you have endless formulae. Here you have the least formulae and another thing. It is a chapter of logic. The chapter of logic and application of brain. Okay. And very basic calculations are done here. So use your common sense or logic that will also help you to understand this question. What is written here? See, you have three trousers. Okay. Let me do one thing. Let me name the trousers. Suppose trousers have these names T1, T2, and T3. First trouser, second, and third, like that. Okay. We have two shirts. Let me name them S1 and S2. Okay. We usually differentiate between shirts through their colors or whatever. Here I am giving the names. Okay. Just to make it simple. If a person has to dress up, then what type of combinations he can use? Suppose he decided that he will be wearing trouser T1. So with this he can match shirt S1, or what he can do? He can match shirt S2. What else he could have done? He is picking second trouser T2 and with it he is trying S1 or he may try S2. Similarly, he could have tried trouser third and with this these can be the two combinations. So basically these are the six ways of dressing up. Okay, six ways of dressing up. And actually I have done the actual counting. I have done the actual counting. Actual counting means I'm actually seeing what are the possibilities and I'm counting them. Six ways. Without actual counting. Without actual counting, let me tell you how to use this multiplication theorem and what is the meaning of this work and everything. Okay. So listen, a person can, he is supposed to dress up. So that means he needs a shirt. So a person can wear a trouser in three ways. Now try to understand the language. Okay. There is only one way to wear a trouser. So don't think that how can a trouser be worn in three ways. No. Everybody know how to wear a trouser. Here there is meaning. Meaning is different. A wear a trouser in three ways means that means he has three choices. Either he can wear T1 or he can wear T2 or he can wear T3. So this is the meaning here. Okay. This is the meaning here. So what is the work? What is the first work? Let us say wearing trouser is the first work. So this can be done in three ways. Three ways means T1, T2 or T3. You can say choices also. All right. Now after this, he can select or wear whatever you say a shirt in two ways. So as I said in the previous case, the concept of wearing shirt everybody knows. Okay. So he is not actually wearing shirt in two ways. Okay. There is only one way of wearing a shirt, but Two ways means two choices. Either he can select S1 or he can select S2. So now that he can select, he can do first work. Listen carefully. That means he can do first work in three ways, and second work following it can be done in two ways. Therefore, number of ways in which he gets dressed up. Number of ways in which he gets dressed up will be equal to m into n, that is 6. Okay. I have taken a lot of time to explain this concept with the help of a simple example, because see, counting can also be done and I can go for multiplication theorem also. Now you may say, sir, I will just do the counting. Why to do all this? Okay. But what if he has so many choices? Let us say a person has 64 trousers and 54 shirts. Okay, then 64 trousers mean that you are going to write T1, T2 up to T64 and S1, S2 up to S54. Are you going to make pairs like this and count them? Okay. He will change the pair and you won't be able to do the counting. So that means you should opt for multiplication theorem in that case. A person has 64 trousers. That means a person can wear a trouser in 64 ways. Now after this he can wear the shirt in 54 ways. So total number of ways in which he can dress up, 64 into 54. You will get the answer. Don't go for actual counting. This is the chapter. We are learning how to count with some faster techniques. One of them is multiplication theorem. Okay. This was just one example. You will find so many after this. I hope you have understood this thing. So following it is important. Okay. Somehow both the works are related to each other. Okay. Somehow both the works are related to each other. Dressing up consists of wearing a trouser and a shirt. Okay. Let me take some more questions. Okay. Here is the question. Suppose there are four routes from city A to city B and six routes from city B to city C. In how many ways? In how many ways a person can travel from city A to city C via city B? This is the question. Very easy one. Anyone can answer.
So 24.
Yes, correct. So question is obviously very easy. We can just make some rough diagram. From A to B, we have these four routes. Okay. And from B to C, we have these six routes. Okay. And you are asked to travel from A to C through B. Okay. There's no direct connectivity. You have to move like this only. So no problem. I am writing four ways. So what will be the language? Language will be that first work can be done in four ways means a person can travel from A to B in four ways. Following which, so into will come. Following which, he can travel from B to C in six ways. As a result, there will be 24 ways of reaching. There will be 24 ways of reaching C from A via B. And if you want, If someone is interested in actual counting and wasting their time, then they can do this. They can give the names of the roots like this. Okay. So journey can be completed like A to B from R1 and B to C R1 dash. So out of the 24 ways, one of them is R1 R1 dash, then R1 R2 dash, then R1 R3 dash, and this can go on. And how many you will write? 24 combinations here. Okay, 24 roots. Instead of this actual counting, I am going for multiplication theorem.
So such questions can come for 1 mark.
Yeah, obviously, because multiplication theorem is only involved, and it will depend on the question, but generally they are solved in one line only. And please use the language. Okay, use the language. You are class 11th student, so I don't think you need to. I need to write everything here. So four ways means what? A number of these are the ways. You will write it like this. The person can move from A to B in four ways. So just write it like this, and he can move from B to C in six ways. Therefore, the total number of ways in which he can travel from A to C via B is 24. Okay, 4 into 6, 24. You write it like this. Just a minute. I am finding some question. Okay, now this is the question. How many how many two-digit even numbers? How many two-digit even numbers can be formed from the digits? How many two-digit even numbers can be formed from the digits? 1, 2, 3, 4, 5. If the digits can be repeated. If the digits can be repeated. Okay, they have given you 5 digits. They are saying that digits can be repeated, but you are supposed to form two-digit numbers only, and they should be even. Can you give me any example which will be the solution of this question? Any one example? Like this will be the part of the answer.
So 24.
24. See, yes,
12.
this is 12. Yes. So both of them are the answers. Why? Because see, they have been constructed using these digits only, and they are even numbers as well, and they are two-digit number. Can you tell me some more?
So
20.
So 14.
14. Yes.
55.
55. Wait a minute.
42.
Wait a minute. Wait a minute. See, 55 is okay if they are not asking for even number, right? Two digit is okay. 55 is two digit. It has been formed with the help of these digits. That is also okay. Digit can be repeated. That is also fine. But is it even number? No. Okay. So that is why it will not be the answer. Yes. Anyone else?
So
20.
42.
42.
42. Yes.
So 44.
So
22.
44, 22, 32. Yeah. 7.
So 52.
52. We are doing actual counting. All right.
52.
Everyone, listen carefully. 52. 8. Till now, we have written 8. Anyone? Any other number? Which one?
Sir,
Any?
38. 34.
34. Yes, 34 was not here. Any number
So
which is not
54.
written here. 54. 54. Right. 54. Any other number?
So 20.
20. How you are getting 20? Where is 0 here? Are you getting it? Read the question from the digits. You are allowed to use 1, 2, 3, 4, 5. You are supposed to make two-digit numbers. They should be even. Digits can be repeated. So 20, how can you say 20? Where is 0 here in the question? Okay. They are not asking all two-digit even numbers. They are asking only those numbers which can be formed here. Any other number that you can find. So how many are these? There are, I think, 10. 1, 2, 3, 4, 5, 6. Yes, 10 numbers, which you have actually got by calculating. Sorry, counting. Without counting, I will get this in one step. See this, 2-digit number make 2 boxes, 3-digit number make 3 boxes, 4-digit number make 4 boxes, and so on. So 2-digit number, and the rightmost box is units place, left one is tens place. Okay. So tell me, I will write it like this. The units place can be filled in. Can be filled in. Can you tell me in how many ways you can fill the units place?
5.
So 2.
Not 5. This is the question. Now
So
actual
2.
chapter starts. Yes. Now actual chapter starts. You will have to think. You can't give answer like this. Number should be even. If number is even, how can we say that they will end with 5 options or 5 ways? You can't put 5 here. You can't put 1 here. You can't put 3 here. How can it be even then? So you know that a number is even if it ends with 0, 2, 4, 6, 8. So how many digits are there which support this that it becomes an even number? 2 digits are there. So units place can be filled in 2 ways. What are those 2 ways? Either the number can be 2 or it can be 4. Following which tens place can be filled in. Following which tens place can be filled in. Can you tell me how many ways?
So 5.
5 ways. Yes, correct. Can be filled in 5 ways. You know why? Because repetition of digits is allowed. If you have written, let's say, I said that units place can be filled in 2 ways. Suppose 2 ways means either 2 or 4. Suppose I have written 4 here. Then is it that I cannot use 4 again? I can use it. Why? Because repetition is allowed and 44 is here. It is present here. So what I want to say, units place can be filled in 2 ways because it has to be an even number. And tens place, no problem. 1, 2, 3, 4, 5. Put any number. 5 ways. Therefore, total numbers question is over. Total numbers equal to 2 into 5, that is 10. And you know what? You will not have to think if any number is missing or not. Here, after like writing 9, I asked what is the next number or anyone remaining. Then some of you are thinking. Then one of you told me 54. But here we have to think. Here we have to think a lot of things. Nothing is missing. Anyone is not left out. But there will be no problem as such if you use the multiplication rule. Okay. This is the meaning of the question. So numbers on like questions on the numbers. Questions on making or creating numbers, they can be a part of this. Let me take some more questions.
So
Yes.
they would say that repetition is not allowed and the 6 ways.
I'm not able to hear you. Please repeat. You are not audible. Please repeat.
Sir, they would say that repetition is not allowed and there would be 6 ways.
6 ways. If
Yeah.
repetition was not allowed. Okay.
Yes.
If repetition was not allowed, then 8 ways. You know why? Because you know why? Because see, units place can be filled in 2 ways. Let me solve it. See, he's asking, what about if the digits were not repeated? Then let us put cross here first in actual counting. Digits not repeating, 44 not allowed. What else? 22 not allowed. Rest everything is okay. Rest everywhere the digits are different. So you know what will happen in actual counting. Sorry, without counting if the digits is not repeated. Units place can be filled in 2 ways, while the tens place will be filled in 4 ways. Why? Because when you say that units place is filled in 2 ways, 2 ways means you have 2 options. You are not actually writing digits there. How can you write 2 digits in units place? Will it make any sense? So what is the meaning of 2 ways? 2 ways means either you can put 2 here or you can put 4. So like if you are putting 2 here in the units place, that means 2 is blocked. So how many digits are remaining now? 4. So now this place, tens place will be filled in 4 ways. That is the case when digits are not repeated. In fact, I was taking next example on that only. This will help you understand even in a much better way. How many three digit numbers can be formed from the digits 1, 2, 3, 4, 5? Assuming that there are two parts. Assuming that first part is repetition of digits is allowed. Repetition of digits is allowed. Second part is repetition of digits is not allowed. See, if you follow NCRT for a school, okay, then 7.1 and 7.2 you can try these two exercises. In fact, you can finish them. I'm talking about NCRT class 11 7.1 and 7.2. If you follow some other book, okay, any book, then in that you go through the chapter and find which exercise is based on factorial. You solve that, okay. You will come to know. You will see the exclamatory sign there, so you will understand that it is based on factorial. Solve that exercise, and generally the first exercise is on multiplication theorem only. Okay, so first exercise will be based on multiplication, and the second one will be based on factorial, just like in NCRT. So please do those questions. Okay, they will help you understand the chapter in a much better way, and you will be prepared for your school exams well before time. Okay, chapter is easy. First thing, keep this in mind. All right, first question, first part. Three digit numbers. I told you according to the digit number, make the boxes. So here we are going to make three digits. Sorry, three boxes. Why? Because now the number has to be a three digit number. However, no condition is given that it is even or odd. So it is easier question. First part, repetition is allowed. Five digits are given. You have to form three digit number. Make three boxes. Can anyone tell me how many numbers will be formed when repetition is allowed?
So 125.
Very good. So it is that easy. See, number of uh, three digit numbers. Number of three digit numbers. When repetition is allowed. When repetition is allowed. See, here we have three places. Ones place, tens place, hundreds place. So you can start by filling any box. It doesn't matter. Let's say you start by filling the units place. So you have five options for that. You can write one into two. Sorry, you can either write one here or two or three or four or five. Now, since we are solving the first part and repetition is allowed, that means for the second box also we have five options, and for third box also we have five options. So following by ones place, we fill the tens place, then we fill the hundreds place. So number will be completed when all the digits will be filled. That means 125. So you know what? With the help of these digits 1, 2, 3, 4, 5, if you start making three digit numbers, you will get 125 numbers. Now, are you thinking of counting them by actually writing them? Forget about it. 125 won't be able to. Number of three digit numbers without repetition. That means now you cannot use the digit that you have used. You cannot use it again. Okay. Number of three digit numbers when repetition is not allowed. Now, not the one who
The
has given the
60,
answer of the first part. I want someone else to give the answer. Second part,
the 60,
60. Anyone else? I'm not saying it is right or wrong. I'm asking anyone else. What your answer for the second part? Repetition is not allowed. Anyone else who can explain also? Explain the answer.
So there are five. There are five ways in which it can be repeated now.
Five ways in which it can be repeated. Digits can be repeated. Yeah, because there are five digits, no? 1, 2, 3, 4, 5. So for every box, you have five options. That is why 5 into 5 into 5. What about the second one?
Sir, in the first block, you can fill in 5 ways.
Yes.
And then in the second block, you can fill only in 4 ways. And then in the third block, you can fill only in 3 ways. So it's
Absolutely. Absolutely. Correct.
5 into 4 into 3 into 6.
Yes. See, it is easy because now the situation is different. Now you are not allowed to repeat the digit used. So when we say that we have five options to fill the units place, five options mean either you will be writing one here or you will be writing two or three or four or five. Okay. So, but actually in one number only one digit will be blocked. So at that time, when any digit is written, let's say 3 is written in the rightmost box. So now 3 is not available for the middle box. Okay. How many options are left? 1, 2, 4, 5. Four options. Now 2 digits will be blocked. So what about how many digits are left for the leftmost box? Only 3 digits. So that is what I'm saying. Repetition is not allowed. So number of ways is 5 into 4 into 3. That will give you 60 numbers. Okay. Okay, there's the next number. Read the question very carefully. Okay, do not give the answer in a hurry. That is not important. Giving wrong answer quickly is useless. How many five-digit telephone numbers? How many five-digit telephone numbers can be constructed? We are going to make some series of numbers. Okay, can be constructed using the digits 0 to 9 if each number starts with 67. Okay, series is starting with 67. Okay, starts with 67 and no digit appear more than once. Another way of saying that digits are not repeating. No digit appears more than once. This is the question. Very simple question. Five-digit telephone numbers you have to make. Okay. Digits to be used are 0 to 9. That means all the digits. You are supposed to make five-digit telephone numbers. Make 5 boxes. Okay. Numbers have to start with, each number start with 6, 7. Digits should not be repeated. How many such telephone numbers are there? Tell me what is the answer. Okay, tell me one thing. I want to ask you a question. Tell me one thing in how many way you can fill this box. I'm making the arrow. How many ways you can fill this box?
So only one way.
One way, only one way. Why? Because number has to start with 67. So that is why in how many ways you can fill this box? One way. Now only three boxes are remaining. Question is easy. Who can tell me how to fill these three question marks? How many ways? How many ways? How many ways? Just find the number of ways, multiply them, you'll get the answer.
8 ways, 7
So
ways, and 6 ways.
One at a time, please. Yes. Yes, any one of you, please speak.
so 8 into 7 into 6.
Okay, I will keep your answer. Anyone else?
7 into 6 into 5.
7 into 6 into 5. One of you are saying 7 into 6, 8 into 7 into 6, and another one is saying 7 into 6 into 5. Anyone else? Anyone else getting any other answer? See, this question mark can be filled in 8 ways. You know why? Because total number of digits are 10, not 9. Because digits are from 0 to 9. 10 digits are there, but now you cannot use 6 and 7. Why? Because it is clearly mentioned no digit appear more than once. So only 6 and 7 cannot be used. So how many are remaining? 8 are remaining. So for this question mark, we have 8 ways. But now what will happen? One more digit will be blocked apart from 6 and 7. Because of this third box, one more digit will be blocked. So how many ways are remaining for the next one? 7. And how many are remaining for the last one? 6. So how many numbers will be there? Number of telephone numbers will be equal to the product of these ways. Number of telephone numbers will be 1 into 1 into 8 into 7 into 6, that is I think 336, 56 into 6. Yes, 336. So these many telephone numbers will be starting from 6 7, which will be constructed using these digits 0 to 9, and no digit will be repeating in those telephone numbers. Okay. 8 into 7 into 6. This is the way to do it. Next question. It is not like that only numbers on like 2 digit, 4 digit number or such type of number questions on numbers are not only there. Multiplication theorem is a vast application. Like trouser and shirt example was there. Then we started solving question on numbers. Now I'm giving you another question. Just try to pick the question and see if you can use it using solve it using multiplication theorem. So question is, there are 4 flags of different colors. Given 4 flags of different colors, how many different signals? How many different signals? How many different signals can be generated? Can be generated if a signal requires the use of if a signal requires the use of two flags, use of two flags, one below the other. See, before you come for the next class, please revise today's class, please. It will help you understand things in a better way. This is the question. 4 flags of different colors. How many different signals can be generated if a signal requires the use of two flags, one below the other? See, tomorrow also we will not be discussing that trigonometric equation. We will take it in the next week. Okay. Next week, whatever will be the first class, in that class we will be discussing trigonometric equation.
So I got disconnected. Can you scroll up? I will take a screenshot.
Yes, sure. Done?
Done, sir. Thank you, sir.
All right. Welcome. Yes. Next question. 4 flags of different colors. How many different signals can be generated if a signal requires the use of two flags, one below the other? I think it is very easy. So basically, this is your first flag and this is your second flag just below it. And you have 4 flags. 4 flags. Let me do one thing. Just for the sake of understanding, red, blue, white, yellow. Okay. These are actually the
Is the
flags.
answer 12?
Yes, 12 is the answer. Very simple. So basically you have 4 flags. 4 flags. I have mentioned the colors here: red, blue, white, and yellow. Okay. You are supposed to make a signal, generate a signal. What is a signal? They have given that. Signal means putting one flag below the other. It is clearly written. Signal requires the use of two flags, one below the other. In how many ways we can generate the signal? So very easy. This place can be filled in. 4 ways, or this place can be occupied in 4 ways. Why? Because we have 4 flags. So put any flag of any color here. Now that particular color will be blocked. It cannot be used again because we have only 4 flags. So you can't say, sir, is the flag repeated? No, 4 flags only. So suppose red color is used here. Then how many options are remaining for the below one? Only 3. So what we say for the first here, the top position, 4 options are present. While for this place can be filled in 3 ways. So ways means what? Flags here. Okay. So total number of ways to make the signal. Total number of ways to make the signal. 4 into 3, right? 4 into 3, that is 12. Now if you want, you can do it later on. Just make different combinations like, see, red above, blue below, RB. Next one will be BR. Then BW, WB, WY. Like that you will get 12 different signals. Okay. But that will be actual counting. Do not do the actual counting in exam. Okay. Always do it by this method. Okay. Multiplication theorem. Now finally, I will just take 5 minutes more because this is not that important. However, we have to study. You studied multiplication theorem. Now we will understand addition theorem, but it is much simpler and it is not that much in use. Mainly questions are asked from multiplication theorem. It says that if a work can be done in n ways, can be done, work can be done in m ways, and another work independent of it, very important, and another work, so not following it, independent of it, okay, it has nothing to do with first work, independent of it, can be done in n ways, can be done in n ways, then just a minute. Then number of ways in which either work can be done is m plus n. So basically it is about independent, nothing to do with the first work. Obviously we need an example. Okay. I will take one previous example to understand what exactly is the purpose of addition theorem or where it will be used. Same question. Suppose there are 4 routes. Suppose there are 4 routes from city A to B, A to city B, and 6 routes from city B to city C. In how many ways? In how many ways? You will understand why not multiplication theorem is used here. Okay. In how many ways can a person leave city B? Can a person leave city B? This is the question.
Can you please scroll up a bit? Done.
Yes. Okay. So A, B, C. These are the 4 routes. Okay. A to B, and these are the four routes to, sorry, six routes. 1, 2, 3, 4, 5, 6. Okay. Now can anyone tell me? Person is there in city B. He want to leave city B. How many ways he can do so?
10.
Yes,
So
simple.
10 ways.
Yes, simple. 4 plus 6. Right. Now we are not multiplying. Now we are not multiplying because see a person leaves city B, leaves city B if he goes to city A, or see, this is independent. If he is going to C, what it has to do with city A, and if he is going to city A, what it has to do with city C. Got it? So that means both of the things are independent. He is moving from B. Either he can go to A or he can go to C. Also remember one thing. This is a very common concept. I think we have discussed it previously also. Whenever the word or is coming, or stands for plus, or stands for plus, and whenever and word is coming, and stands for into. So try to identify try to understand the question, language of the question, and from there you will understand whether you have to use the word or the word and. See, in the first or second question, the same language was there, but in that question they asked that in how many ways he can travel from A to C via B. So what happened in that case? First, he will travel from A to B and then from B to C. So the word and was coming. But here the word or is coming. Because why? A person leaves city B if he goes to city A or city C. Or word is coming. So in how many ways he can go to city A? Four ways. In how many ways he go to city C? Six ways. Six routes are there. Or stands for plus. In how many ways he can leave the city? B. 10 ways. Now you want to do it through counting. See, he can move from B to A via route R1 one way. Another way R2. Another way R3. Another way R4. These are the four ways. You want to leave city B and go to C, you have six options R1 dash, R2 dash. So if you will count all of them, you will get 10 ways. But instead of doing this, we go for addition theorem. Okay. So there are so many ways to understand independent, the word or, okay, not depending on the other work. So like that, you can understand that we are supposed to use addition theorem there. Okay. I am taking the last example for today. Then tomorrow we'll continue from here only. And please come and revise before you come for the next class. All right. Last question. Very simple, very basic. So addition is not that difficult. Even an ordinary person without knowledge of permutation and combination can solve question on addition just by logic. Like here is a question. In a class, there are 15 boys and 10 girls. In how many ways a class monitor can be selected or can be made or selected or whatever? Simple question.
So 25.
Yes, that is it. Simple answer. It is very obvious. There are 25 students in the class. All have the equal opportunity to become the monitor. So a teacher has like 25 options. He can go and select anyone. So like 25 ways are there. This is like basic counting, basic logic. Okay. What about if we want to do it addition principle? Just listen to me, write yourself later on. A teacher can either select a boy or a girl. Okay. A teacher can either select a boy or a girl. So selecting a boy has how many ways? 15 ways because there are 15 boys. So one boy can be selected in 15 ways. Means boy 1 or boy 2 or boy 3 like that. Or what he can do? He can select girl. So there are 10 ways. So in how many ways a monitor can be made? 15 plus 10. Because if a girl is selected, then it has nothing to do with boy being selected or not. All right, both are independent. Got it? So a class monitor bracket you will write boy can be selected in 15 ways. A class monitor bracket you will write girl can be selected in 10 ways. Number of ways in which class monitor can be selected: 15 plus 10, 25. Last question. Can you tell me why 15 into 10 will be wrong? Why plus, why not into? What will happen if I write into, that is 15 into 10? Why will it be a wrong answer?
So that would suggest we need a pair of monitors.
Very good. That means in that case, we are basically making two class monitors. And it is clearly mentioned a class monitor can be made. Because if you write 15 into 10, so you will say that a boy can be selected in 15 ways and a girl can be selected in 10 ways. Therefore, number of ways in which a girl and boy can be selected 15 into 10. So that will be like making two monitors. But here they are asking only a class monitor. So it will be plus and not into. I hope you understood. Okay. So I'm repeating it for the third time. Please come. Uh, please revise and then you come for the tomorrow's class. All right. Otherwise, things will mix up and you will be confused. That is your today's homework. Trigonometric ratios next equation next week we are discussing. Okay. Any first class of the next week we'll be discussing that topic. So that's it for today. Thank you very much.
Thank you, sir.
Thank you.